Let me use this medium to thank my subscribers, to show my appreciation to everyone. I got 1,000 subscribers a few days ago. I really appreciate your support. Hello everyone, you are welcome to a series of videos on the second topic, which is vectors. Let's have a quick revision before we jump into the first question, which is question 22, paper 058022, May June 2018. A vector is a quantity that has magnitude as well as direction. You can denote a vector by either A, B with an arrow indicating the direction, or you can simply use A and put a bar on it. So if you look at this vector AB, the point A is called the initial point and point B is called the terminal point. So the distance between them is called magnitude. Let's say you have a line like this. Point A will be somewhere here and point B will be here, and the direction is like this. So point A is referred to as the initial point and point B is referred to as the terminal point. So the distance between them is referred to as magnitude, or simply length. As far as Igcse mathematics syllabus is concerned, you just have to know the following under vector. The first one will be addition and subtraction of vectors. Let's take this instance. If you have vector u to be equals to 2a add 3b and vector v to be equals to 4a add 5b, then vector u add vector v will be equals to 4a plus 2a, that will be 6a, then plus 3b plus 5b, that will be 8b. So that will be the addition. Then vector u subtract vector v will be equals to 2a minus 4a, that will be negative 2a. Then 3b minus 5b, that will be negative 2b. Then you may want to factor out negative 2 here. So you have negative 2 into a add b. So this is a add b. So this is how you add or subtract vectors, and it could be in form of scale vectors. It could be in form of a column vector. Take for instance, you could have vector x like this to be equals to 2, 3, and vector y to be equals to negative 4 and 5. So in this case, you can add the two vectors together. So let's find vector x add vector y. So when you add them as a column vector, so it's still the same thing you have to do here. So it will be, this should be vector y. Okay, so it will be 2 add negative 4, that will be negative 2. Then 3 add negative 5, that will be negative 8. So this will be the product in form of column vectors. And you can as well also have vector x subtract vector y. So this will be 2 minus 4, that will be 2 plus 4 to be 6. Then you have 3 minus 5, that will be negative 2. So you can see any of these two forms when you are writing your exam. So the next one will be multiplication of a vector by a scalar. Okay, so let's say you have a vector, let's say v, to be equals to 2, 5, like this, okay? Then you want to get 2v, so this will be equals to 2 into bracket 2 into 5, okay? And that will be equals to 4, 10, like this. So this will be 2v, and you could have vector u to be equals to 3a plus 5b. Then you want to get 3u, that will be 3 into 3a plus 5b. So this will be 9a plus 15b. Okay, so that will be the solution there. So let's go to the second part. We are done with that will be the third part. The first part is addition and subtraction of vectors. The second part is multiplication of a vector by its scalar. Then the third one will be magnitude of a vector. So to get the magnitude of a vector, you have to use a formula. Let's take, for instance, vector u is equals to x, okay, then plus y, for instance, okay. So the modulus or the magnitude of vector u, okay, will be equals to square root of x squared plus y squared. So this is what you get, okay. And you could have your vector u in form of a column vector, that is x against y, like this. So it's still the same formula. So let's look into an example. Let's say vector u is equals to 2, 3. Okay, so you want to find the magnitude of u. So the magnitude of u, denoted by this, will be equals to square root of 2 squared plus square root of 3 squared. So this will be square root of 4 plus 9, and this will be square root of 13, and that will be approximately 3.61. So this is how you get the magnitude of a vector. So the fourth one will be vector geometry, okay. So in Igcse mathematics, so you have to be good at vector geometry. When it comes to vector geometry, you should be used to three things. The first one is representing vectors by directed line segments, and the second one is for you to be able to work with position vectors, and the third one is for you to be able to work with collinear and coplanar vectors. So let's look into vectors by directed line segments. So let's say you have vector u to be equals to 2, 3 as a column vector. So if you want to represent it by a directed line segment, so that means you have to move towards x 2 times, okay. That is 1, 2. If you start from here, okay, so 1, 2, then you go up 3 times, 1, 2, 3. So it will be here. So you can easily draw a line from this point to this point, and the direction is like this. So this will be vector u. You can denote it like this, okay. So let's say you have another vector. You have vector v to be equals to -2 against 3, okay. So if you are starting from somewhere here, then we know that -2 means 2 to the left. So you have 1, 2, and positive 3 means 3 up, 1, 2, 3. So it will be here. So you can draw the line like this. So this will be the vector, and the direction is like this. So if you have another vector, let's say vector w, okay, is equals to 2, then -3, okay. So for this one, if you are starting from somewhere here, okay, so we have x to be +2, so you count 2 forward, 1, 2, and y is equals to -3. So 1, 2, 3. So you come down here, then you draw the line from here to this place, and you show the direction, which is the arrow. So this will be vector v, okay, and this is vector w, okay. So this is what we refer to as vectors by directed line segments. So it is very important for you to be able to do this. So the next thing you should be used to is what we refer to as position vector. So a position vector is a vector that is referred to a fixed point, okay. So let's say you have a point here, point P, okay, or let's make it point O, okay. So if you have a line segment like this, okay, so and the direction is like this, so this is P, so vector OP is a position vector because it is fixed to point O, that is the origin. So if you have something like this, it is referred to as a position vector. So for a position vector, the initial point is a fixed point, okay, while the terminal point is this P here, okay. So please take note of this, it's very important for you. And another thing you should know, you should be used to types of vectors, okay. So we have zero vector. So when do we have a zero vector? When the initial and the terminal points coincide. That is, the initial point is A, for instance, and the final point, the terminal point is A. So this is called a zero vector, okay. So you can have A here and A here and put the arrow on top. So this is a zero vector. So the initial point is B and the terminal point is B. So you have a zero vector. That is the first one. So I can write here zero vector. Then the second one will be a unit vector. So a unit vector is a vector whose magnitude is 1, okay. So and it is denoted by a cap. If you have a vector A like this, so the magnitude of this vector A will be denoted by this, okay. So that shows us that this is a unit vector. So it's very important for you to get this. So if the modulus of this vector is equals to 1, then we have a unit vector. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and the direction, okay. So once they are parallel, then we refer to them as collinear vectors. Let's say you have a vector A like this, okay, moving towards this direction, okay, and you have another vector like this, okay, moving towards this direction, something like this, okay. So let's call this vector A like this, and this should be vector B like this. So if vector B is equals to 2A like this, okay, then this vector and this vector are parallel. So how do we know parallel vectors? Is when a vector is a multiple of another vector. So in this case, vector B, which is 2A, okay, so we have vector A like this, and the value of vector A is A. So let's write this. So the value of vector A is A, and the value of vector B is 2A. So A is equals to A, and then vector B is equals to 2A. So you can see that vector B is a multiple of vector A. So because we have this scalar here, so that means vector A, vectors A and B are multiple of one another and they are parallel. So for that reason, we can just generate a formula that if there is a vector A, for instance, and is multiplied by k, okay, so which if there is a vector A which is equals to the product of a scalar factor and this vector A here, okay, then we can say that the two vectors are parallel. So this Ka will be for a vector, while A will be for another vector. Then they are parallel. So in another way, you can say vector A, okay, will be equals to K into B, okay. So this tells us that we have two parallel vectors where K is a scalar, okay. So for this example here, you can have you have vector A and the other one is 2A. So K is 2 here, and for that reason they are parallel vectors. So another one you should look into should be so also you could have it in this form: vector U to be equals to, let's say, M, then vector V to be equals to 2M, and vector W to be equals to 3 out of 4M, okay. So these vectors are parallel because they are multiple of one another. So this is a multiple of this, 2M is a multiple of M, so 3 out of 4M is a 3/4 M is a multiple of 2M is a multiple of M. So they are parallel vectors, and you can say that they are collinear. So because they will be on a straight line. So if you want to determine if 3 or 2 or more forces are collinear, okay, so all what you need to do is to find out if they are on a straight line. So that is what you need to do, okay. Another thing you should know very well is when it comes to co-planar vectors. Co-planar vectors are the vectors that fall in the same plane, okay. So we refer to them as co-planar, and you should be able to work with them. So you can have it in form of this, and then you will be asked to find a particular side, and at times you'll be given a side in form of ratio. So let's take, for instance, let's say C, vector BC is equals to A, okay, and you'll be told that the ratio of BQ, okay, to QC is let's say 1 to 3. So from this now, you have to find the total ratio. So the total ratio is equals to 4. Then you can now get BQ. So BQ will be equals to 1 out of 4 multiplied by A. So that means BQ will be A over 4. Okay. And of course, QC will be 3 over 4A because they must add up to 1. So you will see something like this, a lot of these when it comes to vectors. And also you should be conversant with something when you are dealing with collinear, if you are dealing with co-initial vectors, okay. I'll still come to that later, okay. So look at the second diagram here. You are asked to simplify the following vectors, the following vector expressions as much as possible. So for this one, you are starting from D, that is the initial point, so to A like this, then from A to B, then from B to C. Okay, so this will be equals to vector DC like this. So the second one, you have vector DB, okay, minus AB. So I have to rewrite this for you to understand very well, because I can simply write the answer, but I need you to understand it. So you know that this will be DB, okay, minus. So we want to change the direction of this vector. If a vector is moving from A to B, okay, so if you want to change the direction, okay, and you still want them to be the same, then you must put a negative sign before it, then it will now be BA. So you have AB, okay, from A to B is same thing as negative B to A, okay. So instead of having A to B now, so I want to have negative B to A, so that these two can become positive. Then that means I'm moving from D to B, then from B, so I need to move to A, okay. So that means this will be equals to D, sorry, this should be DA, okay. So for C and D, I want you to practice it, and you can comment, give your answer in the comment section below this video. The next type of vector you should also know is a negative vector, okay, that is negative of a vector. So a vector whose magnitude is the same as that of a given vector, okay, but moving in an opposite direction is referred to as negative of a vector, okay. So for instance, let's say you have vector u, okay, to be equals to 2m, okay, and there is another vector v which is equals to negative 2m, okay. So this is called a negative vector. So it means vector u is moving towards this direction, okay, and the minus, so this is vector u, okay, and vector v is moving towards this direction. So they have the same magnitude or the same length, okay. So in this case, you could have vector OP, for instance, to, okay, let's have it like this. So this could be vector OP moving towards this direction, okay, and you can have vector PO, okay, like this, is moving towards this direction, okay. So OP is forward and PO is backward. So in this case, you can say vector OP is equals to negative vector PO. So that is this is a negative vector. You can see that they both have the same magnitude, but they are moving in different directions. So they can be equal when you indicate the negative sign. This negative sign does nothing but to change the direction. So if PO is like this, then if you put a negative sign there, that means it will be like this. So they will be equal. So another type of vector you should be used to is co-initial vectors. Two or more vectors are said to be co-initial if they have the same initial point. Take for instance, you have these vectors, okay, 1, you have 2, and you have 3, like this, and they are both they are all moving from the fixed point or the initial point. So this one is vector P, this will be vector Q, and this will be vector R, okay. So OP, OQ, and OR are co-initial vectors because they have the same initial point. So now let's say you want to find PQ now. So what will be the vector PQ? So vector PQ will be equals to Q minus P. Vector PQ will be equals to Q minus P and not Q plus P. Let me show you. So from P, we want to move to Q. Okay, so it will be PO like this. Then plus OQ like this. But we don't have vector PO, but what? OP. That means we have to change the direction, and that is where the negative vector will be useful. So I'll write PQ to be equals to minus OP, then plus OQ. Then you can have PQ to be equals to, let's rewrite this, OQ minus OP, Then finally you can say P or Q to be equals to Q minus P. Okay, so this is what you need to do. So but once you are used to this, once they have the same initial point, that is they are position vectors, so PQ will just be this. You don't need to undergo this process again. So this is just the little I can give you in form of revision. So let's jump into the first question. So this is paper question 22 from paper 058022 May June 2018. So in the diagram, O is the origin, so that is the origin, and OC is equals to negative 2a plus 3b, and OD, look at this, is equals to 4a plus b. Find CD. So that means we want to move from here, from C to D. So we want to move towards this direction. So let's scroll down a little bit. So CD, okay, will be equals to CO, okay, then plus OD. Okay, so in this case, if you are used to position vectors, okay, so you should know that CD will be equals to D minus C. I just showed you earlier in this video. Okay, so but I just want to show it to you again. So CD, okay, will be equals to minus OC, because we only have OC here. Look at the direction of OC, so we don't have CO. So the arrow is pointing at C, that is, you are moving from O to C. So we have negative that plus OD. Okay, so you can now say that CD, okay, so you can put your arrow like this, okay. So CD will be equals to OD, then minus OC. So this is what you need to do. So in this case, I will say 4A plus B, you can put it in bracket, then minus OC is this, minus 2A plus 3B. So you have to be very careful with the sign. So in this case, this will be 4A plus B. Then let's open the bracket with negative sign. This will be plus 2A, then minus 3B. So 4A plus 2A, that will be 6A. Then plus B minus 3B, that will be negative 2B. Okay, but you may want to factor out, okay, we have to simplify in simplest form. So I'll need to write 6A minus 2B here. Then let's remove this because we need to factor out 2. We have 2 into 3A minus B. So that will be the final answer. You have 2 into 3A minus B. Then part B, DE is equals to A minus 2B. Where is DE? DE equals, okay, look at it here, A minus 2B. Then find the position vector of E in terms of A and B in its simplest form. So the position vector of the position vector of vector E, okay, will be from here to here. That is, let's draw a line here. So this will be the position vector O, that is OE is the position vector of E. OE means we want to move from O to E. So that means we have to start from O, then we'll come to D, then from D we'll come to E. So OE will be equals to OD. Okay, you can show the arrow here, plus DE. So that is what we'll get there. So let's scroll down and write here. So OE, okay, it will be equals to D, let's scroll up, OD, it will be equals to OD, okay, then plus DE. So it will be equals to OD is equals to 4A plus B. You have 4A plus B plus DE is giving us A minus 2B. So this will be equals to 4A add A plus B minus 2B. So this will be equals to 5A, then plus B minus 2B, that will be minus B. So that means the position vector of E will be equals to 5A minus B. So let's go to the next question. Question 14 of paper 058023 May June 2018. O is the origin. Vector OP equals to P. Vector OQ is equals to Q. QT ratio TP is 2:1. So find the position vector of T. So the position vector of T will be from here to this place, and the direction will be this. So we need to firstly get QP. So to get QP, okay, since vectors OQ and OP are position vectors, so it will be OP minus OQ. I've shown you that already. So, and if you are still confused, okay, so you can just say that QP will be equals to QO plus OP, and this will be equals to minus OQ plus OP, and that will be OP minus OQ. Okay, so you still get this. Okay, so it will be equals to OP is equals to P, then minus OQ is equals to Q. So this is the value of vector QP, and we need the value of this. Okay, so what we want to get is OT, and OT will be equals to, from here you can see we want to get OT, so that means you move from O to P, then from P to T. Okay, so to get OT, so you go to OP, then you go to PT. So that is what you need to do. So don't forget that these vectors QT will be moving towards this direction, and TP will be moving towards this direction. Okay, so that means our OT will be equals to OP, then minus TP, because we don't have vector PT, but we have TP, so I have to change it. So that is what we need to do. Okay, so we need to find TP. Already we know that OP is equals to P, so let's find TP. So to get TP now, okay, it will be vector TP, so it will be equals to the ratio of vector TP is 1 over total ratio, which is 2 add 1, that is 3, then multiply by QP, which is this, multiply by P minus Q. So this will be the value. So I can now substitute it inside this one here. So that means OT will be equals to OP, which is P, then minus 1 over 3 into P minus Q. So we need to simplify this very well, so to leave the answer in the simplest form. So we can open the bracket. If we do that, okay, let me erase this to have more space up here. So we can easily say P, then minus 1 over 3 times P, it will be minus 1 over 3P, then minus 1 over 3 times minus Q, that will be positive 1 over 3Q. Then we can do this. This is 1P minus 1 over 3P. So that will give you 2 over 3P plus 1 over 3Q. So 1 over 3 is common to the 2. So you can say 1 over 3 into, so you'll be left with 2P here, then plus 1Q here. So this will be the final answer. So I can write 1 over 3 into 2P plus Q. So you can close the bracket. Let's go to the next question. That will be question 26 of paper 058023 October November 2018. In the diagram, OABC is a parallelogram, OABC. Then OP and CA intersect at X, and OP, this is OP, and then CA, this CA, they intersect here, at point X, and CP ratio PB, that is CP, this one here, you can put a line here, CP, then ratio PB, this one here, that's from here to here, and from here to here, they are in ratio 2 to 1. So once you know the value of CB, then you can get CP and PB respectively. So OA is equals to A and OC is equals to C. So find OP in terms of A and C in a simplest form. So to get OP, we want to get this. So OP and OC position vectors. So I can say that, let's write OP is equals to OC plus CP. That will be the vector OP. So we know OC to be C, but we are yet to get vector CP. So we need to get that. So we know that OA is equals to A. So automatically CB will be equals to A as well, because opposite sides are equal. So this will be A. Then we need to get CP. So using the given ratio. So the total ratio is 2 add 1, that is 3. So CP will be equals to the ratio of CP 2 over total ratio, that is 3 multiplied by vector A. So multiplied by A rather. So this will be CP. Then I can now key in the value here. So OP will be equals to OC, which is C, then plus CP, which is 2 over 3A. So if you want to simplify this further, so you need to multiply 3 by C. That will be 3C, then plus 2A, then everything over 3. So we want to simplify it like this. But I think it's better to leave the answer like this because it's pretty easy to work with. So I can write the vector position vector OP to be equals to C plus 2 over 3A, or 2 over 3A plus C. So anyone you have is okay. So let's go to part B. CX ratio XA. So that is CX ratio XA is equals to 2 to 3. That means the ratio of this one, let's say something like this. So this is 2 to 3, 2 to 3. That's not their values, So find OX in terms of A and C in the simplest form. So we want to find OX, that is this position vector here, OX. So we have two options. So to get to X from O, you can either go through OA, then AX, or you can either go through OC, then CX. So the choice is yours. So if you want to get OX, it is very important for you to get the value of CA. So CA will be equals to CO plus OA. So let's write here. So CA will be equals to CO plus OA. So that is the value. But we don't have CO, we only have OC. So we'll change it and add a negative to it. So this will be equals to negative OC then plus OA. Okay, so you can simply say CA is equals to OA minus OC. So I'm just showing you this for you to get used to it. Okay, so this will be equals to vector OC is equals to C. So we're going to have minus C then plus vector OA is given as A. So this will be equals to A minus C. So we want to get vector OX. So we need to get either CX or XA. Anyone? So since we have found CA, it is easy to find either of CX or XA. So let's take a stand. So we want to get OX. Let's go through this route. That is OX equals to OC plus CX. Okay, so OX equals to OC plus CX. This is the route we want to use. Let's key in the values. OX will be equals to OC is C, then plus CX is 2 over 5 into A minus C. So we'll need to expand the bracket. We have plus 2 over 5 A minus 2 over 5 C. So C minus 2 over 5 C will be 3 over 5 C plus 2 over 5 A. That will be the answer, and you can write it as 2 over 5 A plus 3 over 5 C. So let's go to the next question. Question B, Roman figure 2. Find OX ratio XP. We've already found OX, and the value is 2 over 5A plus 3 over 5C. So we can write it here, or let's keep it here. Then we need to find XP. So if you go back to the diagram, you see that XP is equals to XC then plus CP. Okay, XC plus CP, that will be the value of XP. So let's scroll down a little bit. We can work it out. So we can say that XP will be equals to XC plus CP. So don't forget to show the direction of the vector. Then we don't have XC, but we have CX. So we can change this to minus CX, then plus CP, okay, which is the same thing as CP minus CX. So let's key in the values. So CP is 2 over 3A, then minus CX is 2 over 5 into A minus C. So we've already found CP and then CX respectively. So we can expand this bracket. If you do so, you will get 2 over 3A, then minus 2 over 5A, then plus 2 over 5C. So this and this are similar, so you can combine them together. So it will be, if you have 2 over 3A minus 2 over 5A, so if you subtract this, you will get 4 over 15A, then plus 2 over 5C. So if you find the LCM and simplify, so the LCM of 15 and 5 is 15. 15 divided by 15, that is 1. 1 times 4A, you get 4A. Then plus 15 divided by 5, that will be 3. 3 times 2C, that will be 6C. So this will be the value of xp. Okay, so we want to get the ratio ox. Ratio xp is the same as ox divided by xp. So ox is 2 over 5. Okay, let's scroll up. I think we did that already to save time. So let's check ox up here. Ox. Okay, so this is ox here. So we can simplify this. Okay, so let's scroll down a little bit. So ox is equals to 2 over 5a plus 3 over 5c. So since they have the same denominator, so you can rewrite it as ox, okay, to be equals to 2a plus 3c over 5. Okay, so divided by, this is ox, then divided by, okay, let's write it 2a plus 3c over 5. So divided by xp, which is 4a plus 6c over 15. So let's change the sign of division to multiplication. So that will be 2a plus 3c over 5, then multiplied by 15 over 4a plus 6c. So we can actually simplify this further. So let's factor out 2 from the denominator here, from 4a plus 6c. So that will be 2a plus 3c over 5 multiplied by 15 over 2 into bracket 2a plus 3c, so that 2a plus 3c will cancel out 2a plus 3c. Then 5 goes in 5 once, 5 goes in 15 thrice. So we have 3 over 2, which is the same as 3 ratio 2. So let's go to the space here. We have 3 ratio 2 as our final answer. So let's go to the next question. Question 11A of paper 058041 May June 2018. Okay, so we are given 3 vectors. We are asked to find the modulus of vector OB. So we can sketch this if you want. It makes it easier. Okay, so the first vector is OA, and look at the direction. If you move forward 4 times, because x equals to 4, okay, and you go up 3 times, okay, so A will be somewhere around here. So you can have something like this. Okay, so this will be the direction of vector OA. And if you look at the next one, which is AB, x equals to 8 and y equals to -7. So that means it will be coming towards this direction. Okay, something like this. So B will be here, because the x value is +8, you come front, and the y value is -7, you have to come down. Okay, so for the third one, from A, you go to the left 3 times like this, okay, and move up 6 times. That means it will be somewhere up here. So this will be point C. So I can easily draw this one like this, okay, and this will be going towards this direction. Okay, so this is going towards this direction. Okay, so this is just the rough sketch. So let's take that again. So this is the rough sketch of the 3 vectors. So you can put this one here. So this one comes from the origin, and this one comes from the origin. So let's find OB. If you want to get OB from here, you see that OB will be equals to OA plus AB. Okay, it is very clear there. So we have OA to be 4, 3 as a column vector plus AB is 8 against negative 7. Okay, so if you add them together, 4 add 8, so that will give 12, and 3 plus negative 7, that will be negative 4. Okay, so this is vector OB, but we are asked to find the modulus, okay, the magnitude of OB. So to do that, we will write the formula OB. The magnitude of OB equals to square root of x squared plus y squared. That will be square root of 12 squared plus minus 4 squared. So if you do this, you get the value of the magnitude to be 12.6 when you correct it to 3 significant figures. Okay, Roman figure 2, find BC. Look at this. So BC is along this straight line, but okay, we can say BC is equals to BA plus AC. But look at the direction of vector AB is coming downward. So that means this will be equals to minus AB, because we don't actually have BA. So you can write it like that. Okay, then plus AC. So that will be equals to, we have AB, so it will be, you can write it as AC minus AB. So we can key in the values. What is AC? AC is minus 3 against 6. Then this the vector AC minus AB is 8 against minus 7. Okay, so minus 3 minus 8, so that will be minus 11. Okay, then 6 minus minus 7, so the two negative signs will combine together to become positive, and that will be 6 add 7, that will be 13. So that will be the vector BC. Part B, PQRS is a parallelogram with diagonals PR and SQ intersecting at X. So from the properties of a parallelogram, the diagonals bisect each other. That means vector SX will be equal to vector XQ. So also vector PX will be equals to vector XR. Okay, so PQ is equals to A and PS equals to B. Find QS in terms of A and B. So QS will be, we can write it, Q vector QX will be equals to half of vector QS. So we need to find vector QS. So this is pretty easy. So from the diagram, so vector QS will be equals to QP plus PS, which is equals to, we don't have QP, but we have PQ. So that will be minus PQ plus PS. So that will be equals to minus A plus B, which is the same as B minus A. So we can now key in, substitute the value of QS here. So that means QX will be equals to 1 over 2 into B minus A. That is the value of vector QS. So that is the solution to this problem. So 1 out of 2 into B minus A. So let's go to the next question. So that will be question 11 of paper 058042 October November 2018. We have 3 vectors in column vector form. Okay, so find 3a minus 2b. So this will be 3 into negative 3 into 2, then minus 2 into 5 into 4. So if you do this, you get 3 times minus 3, that will be minus 9 against 6. Then you have plus. So let's expand this with the bracket. That will be minus 2 times 5. That will be negative 10. Then you have negative 8. So if you add this together, you get negative 19. That is minus 9 minus 10. Then you have 6 minus 8. That will be negative 2. So you have negative 19 against negative 2. Okay, so 11a, Roman figure 2. Find the modulus of a, or the magnitude of vector a. So for vector a, x equals to negative 3, y is equals to positive 2. So the modulus or the magnitude of vector a will be equals to square root of x squared plus y squared. That will be equals to square root of negative 3 squared plus 2 squared. So if you input this into your calculator, of course this will give you 9 plus 4. That will be root 13, and it will be approximately 3.61. Okay, so you don't need to waste time there. This will be 3.61. 11a, Roman figure 3. You have MA plus MB to be equals to C. Write down two simultaneous equations and solve them to find the value of M and the value of N. Show all your working. So we need to write out this equation in form of matrix. Okay, so M is a value, is a variable. So M into vector A. Vector A is minus 3 against 2, then plus N. N is also a variable. Okay, so it will be multiplied by the vector. So now it's serving as a scalar here. So vector B is given as 5 against 4, then equals to vector C is given as 14 against 9. So we need to form two simultaneous equations from here. So the first one will be m times minus 3. That will be minus 3m plus 5 times n. 5n equals to 14. So this will be equation 1. Okay, so the second one will be 2 times m. 2m plus 4 times n. 4n equals to 9. So this will be equation 2. Using elimination method, so we need to balance the coefficient of any of the variables. So let's balance the coefficient of variable m. Okay, so let's multiply equation 1 by 2. So that will give us minus 6m plus 10n equals to 28. So you may want to call this equation 3. Then let's multiply equation 2 by 3. That will be 6m plus 12n equals to 3 times 9, 27. And you may want to call this equation 4 as well. So we can easily add equations 3 and 4. So if you add this and this together, it will be 0. It has been, m has been eliminated. So if you add this and this together, you get plus 22n, then equals to, if you add this and this together, you get 55. So from here, n equals to 55 divided by 22, which implies that n equals to 2.5. Okay, n equals to 2.5. So let's key in the value of n equals to 2.5 into equation 2. So equation 2 is 2m plus 4n equals to 9. So we have 2m plus 4 into brackets 2.5 equals to 9. So this will give us 2m plus 4 times 2.5 will give you 10 equals to 9. 2m will give you 9 minus 10. 2m will give you negative 1. M will give you negative 0.5. So that means m is equals to minus 0.5. and n equals to positive 2.5. So that is the solution of that simultaneous equations. So let's go to the next question. OAB is a triangle and C is the midpoint of OB. So if C is the midpoint of OB, that means vector CB moving in towards this direction will also be C. Okay, then D is on AB such that AD, that is AD ratio DB will be 3 to 5. Okay, so we can say 3 to 5. So mind you, that is not the value, just the ratio. Okay, then OAE is a straight line such that OA, that is this one here, OA, it will be 2 to 3. Okay, so that is the ratio as well. So OA equals to A and OC equals to C. Find in terms of A and C in its simplest form vector AB. Okay, so from here it is super easy. Vector AB will be equals to AO plus OB. So we don't have AO, but we have OA. So it will be equals to minus OA plus OB. So this will be equals to minus A plus OB is 2C. So which is the same as 2C minus A. So that is vector AB. So 2C minus A. So part B, find AD. Let's see, AD. So to get AD is very simple. AD will be 3 over 8 of AB. Okay, so the whole length here, okay, is what you are sharing between AD and then DB. So for that reason, so we can say that AD, okay, vector AD is equals to 3, that's the ratio of AD over total ratio, that is 3 add 5, okay, that is 8, because if you scroll up, okay, so AD and DB are in the ratio 3 to 5, so the total ratio will be 8. So since we want to get AD, so it will be the ratio of AD over total ratio, okay, so multiply by vector AB, and we just found vector AB to be this. So this will be equals to 3 over 8 into 2C minus A. So 3 over 8 into 2C minus A. So that will be the answer there. So part C, 1B, Roman figure 1, part C, we want to find CE. Let's go to the diagram again. We want to find CE, that is from here to this place. We want to find it. So it will be very easy for you to find CE if you know OE. So it will just be CE will be equals to CO plus OE. So the first thing we need to do is to find OE. Okay, so that is one thing you can do. Okay, but we know that we don't know the value of OE. It will be very difficult to do it, but we know that OA and AE are in ratio 2 to 3, and we know the value of OA, so we can say OA is equals to ratio of OA over total ratio times OE. From there we can find OE, as simple as that. So we can say that OA, okay, so it will be equals to the ratio of OA is 2 over the total ratio, that is 2 plus 3, 5, multiplied by what? By OE. Okay, we already know the value of OA, it is A. So I can say A is equals to 2 over 5 multiplied by OE. So you can make OE the subject of the formula. That will be 5 times A equals to 2 OE. So OE finally will be 5 over 2A. So now that we know OE, so it is easy to find CE. So we have, okay, let's write here, CE will be equals to CO plus OE, and we don't have CO, so but we have OC, so and OC is C, so that will be minus C, that is OC, okay, plus OE, we just found it to be 5 over 2 A, okay, so you can rewrite this, okay, so this will give you 5 over 2A minus C, that is the value of CE. So the next one, part D, we need to find CD. So let's go to the diagram. So CD will be equals to CO plus OA plus AD. So AD will be 3 over 8 of AB. So that is pretty simple, right? And we know AB already. So let's scroll down. Okay, so let's write CD. Let's write the movement. CD will be equals to CO plus OA plus AD. So we don't have CO, but we have OC, and the value is C. So this will be negative C plus OA is given as A plus AD. So we need to find AD from here. So AD will be 3 over 8 times AB. AB is 2C minus A. So we can write the value of AD to be equals to 3 over 8, okay, multiplied by 2C minus A. So if you simplify this, you need to open this bracket. This will be equals to minus C plus A plus 6C over 8, then minus 3A over 8. Okay, so this is what you get. And if you add A plus A minus 3A over 8 will give you 5 over 8A. Then if you add minus C to plus 6 over 8C, that will give you minus 1 over 4C. So that will be the answer there. And of course, you may want to rewrite this, okay, as let's say 5A minus 2C then over 8. If you find the LCM of 8 and 4, okay, you write it as a single fraction. So this will be the equivalent. Okay, so Roman figure 2, CE is equals to KCD. Find the value of K. So CE, where is CE? This is CE here. Okay, we can also rewrite this one. Okay, I think I can show you the working here. So CE is 5 over 2, okay, A minus C. Let's say C over 1. So the LCM of 2 and 1 is 2. 2 divided by 2, 1. 1 times 5A, you get 5A minus 2 divided by 1, you have 2. 2 times C, you have 2C. So you can actually write CE like this. So it will be 5A minus 2C, everything over 2. Then it's equals to K. Then CD is this. So just like the way I rewrote CE to be this, so you can also rewrite this one as this, which has been written here for you. It will be equals to 5A minus 2C over 8. You can put this one in brackets, okay? So from here, what you need to do is to divide this one by this, okay? Because you need to make K the subject of the formula, okay? So if you do that, so let's scroll down a little bit. Okay, so we need to have more space. Okay, so if you do that, it will be 5. Okay, let's write here. It will be 5a minus 2c over 2, then divided by 5a minus 2c over 8 equals to k. Now we need to change this sign of division to multiplication. It will be 5a minus 2c over 2 times, when you change it, you flip the fraction, 8 over 5a minus 2c. Of course, this will cancel this. 2 goes in 2 once and 2 goes in 8 4 times equals to k. So that implies that k is equals to 4. Okay, so let's go to the next question. So this is I think it should be question, okay, it's from paper 058043 October November 2018. Okay, so and this will be the last question in this video. We are given this diagram and we have points A and B respectively. So we want to find the column vector of AB. Okay, so you need to be very careful here. So for vector A, you have to spread it like this. Okay, then you spread it like this to point B. So that is the direction of the movement, like this and like this. Okay, so if you look at the direction here, it should be x equals to 3 here and x equals to 5 here. Okay, so that means from x equals to 3, it took 2 steps, like from 3, 4, and 5. That means twice. X equals to 2. Then for y, here, what's the value of y here? From y equals to 2, it moved to y equals to 6. That means 3, 4, 5, 6. So that will be 4 steps. So the column vector AB will be 2 against 4. Then Roman figure 2, find the magnitude of AB. Okay, so AB is this. That means x equals to 2, y is equals to 4. So the magnitude of vector AB, okay, will be equals to square root of x squared, which is 2 squared, plus y squared, which is 4 squared. So if you input this into your calculator, so of course you may want to simplify this further. This is 4 plus 16 under this radical. So you have square root of 20, and that will be approximately 4.47. So this is the end of the first video, okay, in this series of videos under all Igcse vector questions in 2018, 2019, and 2023.